So we now know this really handy tool for taking derivatives called the power rule. And one of the games that kind of comes out of calculus is you really want to use the power rule when you can. It's the easiest rule for taking derivatives that you'll learn. And so if you can take a function, let's consider a function f of x equal to 1 over x to the 4 power, which right now, as terms of how it's written, is not a power function. So I can't use the power rule yet, but I can use the power rule. We can use the power rule if f of x is in the form of f of x equals x to the n, where again, n just has to be any rational number, which means that n can be negative. So I can't take the derivative of this function as it's written right now. But the easiest tool you're going to have, this idea of the power rule, can be used if I can write this function like this, and fortunately I can. I can start off with f of x equals 1 over x to the 4th, and I can rewrite it as x to a power, that is x to the minus 4 power. So your first step whenever you're looking at a function that has a power function in the denominator is you want to rewrite the function using a negative exponent. And really it's because you want to get it in this form. If you can get any function into this form, you can use this power rule. So I can now apply it and say f prime of x equals, well, remember negative 4 is going to be the new coefficient. And then I need to reduce the power by 1, so that becomes negative 5. So this step right here was all about applying the power rule. Now then, we need to kind of go back and we need to get this into sound form. It's considered bad form to leave negative exponents in your work. Fortunately, it's very easy to go rewrite this again. I can rewrite this as f prime of x equals negative 4. The x to the minus 5 is now going to be in the denominator, written as x to the positive 5. And so the last step is to go in and simplify without negative exponents. So you want to rewrite it with a negative exponent to use the power rule. However, you're obviously going to get a negative exponent because if you reduce it by 1, it's going to stay negative. If I do that, I can then go in and simplify without the negative exponents. So one thing that happens is if I have something that looks like this, notice that the power actually increased by 1 because I reduced 1 from a negative exponent. The other thing that always happens whenever you take the derivative of a function that's in this form is because the power rule says to take this exponent and make it your coefficient, I also had a sign change. So those are going to be a couple of things you're going to notice whenever you take the derivatives of these rational functions where it's 1 over x to some power, is the power should actually increase because of what the power rule does to a negative exponent. But you also should get this sign change because what you're really dealing with is that negative exponent. So this power rule can work for functions that can be rewritten as a negative exponent. And in the next video, what we're going to see is not only does it work for things that can be rewritten as negative exponents, but because we use the power rule and says n is any rational number, we can also use it for any situation where n can be written as a rational exponent, which is going to allow us to take the derivative of all kinds of root functions as well.